सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं इन केमिस्ट्री वाला चैनल रिगार्डिंग टू योर वन एंड ओनली केमिस्ट्री। In previous video, we have discussed about the what is the meaning of batteries and cell. Further, we have discussed about the just types of the cell as a primary and secondary. In primary cell or batteries, we have discussed about the just dry cell and mercury cell. Dry cell, one of the cell which is used in torch and different kinds of these just small torch and just remotes also. While if we'll go with the just another kind of the just primary cell, then that is the mercury cell. Mercury cell is used as a remote in remotes and just hearing aids especially, and just laser torch also there are a lot of use, and important use is in a wristwatch. Wristwatch में जो tablet cell use होता है that is called as just as a mercury cell. We have discussed about the just EMF also. If we'll go with the just mercury cell, then it gives just constant EMF because of the concentration of electrolytes remains constant, while dry cell does not give just a constant EMF. If we'll go with the just drawbacks of the dry cell, then dry cell drawback of the dry cell is just leaking of cell, and while if we'll go with the just mercury cell, then these are not eco-friendly cell. So this was about the just primary cell in short. Now we'll go with the just secondary cell. So what is the meaning of secondary cell and what are the importance about them? So we'll go with the next. This is the second part as a secondary cell. Secondary cell. If we'll go with these cell or just you can say batteries also, secondary cell or batteries, just we can say cell which exists, cell which exists reversible reaction, reversible reactions, and can recharge after use are known as just secondary cell, called as secondary cell. If we go with the secondary cell, then there are a lot of examples, but we'll take just two important example. One of the is your lead storage cell. Lead storage cell, and another is your NiCd cell, nickel cadmium cell. These are the two important examples regarding to the just your secondary cell. Now I would like to go first of all with the lead storage cell. This is the lead storage cell. These stores to the energy as a electrical energy. So we can say stores electrical energy, that's why these called as accumulator. This is the most important word, accumulator, due to storing of just electrical energy. If we go with the structure, then diagrammatically it exists following structure. It will be a fiberglass container like this. This is the container made up of fiberglass, or you can say fiber sheet also. This is the container of fiberglass. This is the container of fiberglass. Container of fiberglass. If we go with the just electrodes, then alternately it will be use of plates like this. You can say 1, this is the 2, this is the 2, This is your three. It will be alternate plates and as a electrode, and this is the fourth plate like this. These alternate plates will be arranged as follows. This is the cathode as positive terminal, and these plates will be in the form of grid like this. पर्टिकुलर एक जाल होगा ग्रीड का मीन कुछ इस टाइप से. This is the grid of just plate, and here will anode. Here will anode as a grid negative terminal, anode again in the form of grid, and particularly एनोड पर जो फिल होगा that will be spongy lead. Here will filling of spongy, you can say spongy lead Pb, and here will just filling of PbO2, lead dioxide, and as electrolyte we will use H2SO4. These plates will be suspended in dilute H2SO4 having the concentration of 38%. This is the just diagram, and this is the lead storage cell. If we'll go with these plates, now what about them? These plates basically are made up of just PBSB plates. These plates are made up of grid of, you can say grid of PBSB, lead and antimony का alloy के through बना होगा, and here is the dilute H2SO4. This is the dilute H2SO4. Dilute H2SO4 as a 38% and having the density as a, you can say just very important, that is the regarding to the density, that is your 1.30 gram per cc, having the density 1.30 gram per cc. This was about the just structure. Now the time to discuss about the reactions, cell reactions. This is the cell reactions. Cell reactions. First of all, we'll take just dilute H2SO4 as an electrolyte, so it dissociates in 4 of H plus 2 of SO4 2 minus. First of all, we'll go with the anode, you can say as a negative terminal. Here's the Pb, just SO4 2 minus, loss of 2 electron, Pb plus 2 and SO4 2 minus forms PbSO4, loss of 2 electron, that's why here will oxidation reaction. If we'll go with the just cathode, anode negative, cathode will be positive terminal. Here's the PbO2, lead dioxide, remaining is your 1 of the SO4 and 4 of H plus. This is the 4 of H plus, 1 of the SO4 2 minus. It also changes in PbSO4, just here will gain of 2 electron, here will reduction process, so gain of 2 electron, here will formation of PbSO4 and 2 of S2O. Here's the gain of electron, so it is known as reduction reaction. Reduction reaction. If we'll go with the net cell reaction, that is also called as discharging reaction. Net cell reaction, or you can say discharging reaction. So what is that? Listen me carefully. This is the net cell reaction. Net cell reaction, or you can call it discharging reaction, क्योंकि पर्टिकुलर एग्जाम में नेट सेल रिएक्शन ना देख करके डिस्चार्जिंग रिएक्शन पूछता है. So it's very simple. 2 electron to 2 electron remains cancelled. Rest here is the Pb. So this is the Pb. This is your PbO2. This is the 4 of H plus. 1 of the SO4, 1 of the SO4, 2 of SO4, 2 minus, changes into PbSO4 and 2 of H2O. So this was entire reaction as a discharging reaction, as a anode and cathode. Now the time to discuss on discharging of cell, concentration of H2SO4 decreases and PbSO4 depletes over different electrodes. So PbSO4 का डिपोजिशन हो जाएगा, H2SO4 का कंसंट्रेशन डिक्रीज होगा, इसलिए इसको चेंज करेंगे. सो आफ्टर जस्ट यू कैन से उसको रिचार्ज करने के लिए जब लेके जाते हैं मार्केट में, तो ड्यूरिंग रिचार्जिंग old H2SO4 solution replaced by another dilute H2SO4. This is the dilute H2SO4 solution, और पर्टिकुलर उसमें करंट का फ्लो करा देते हैं, तो पूरी रिएक्शन रिवर्स हो जाएगी. मीन जहां एनोड पर ऑक्सीडेशन हो रहा था, कैथोड पर रिडक्शन हो रहा था. नाउ इट विल बी रिडक्शन ओवर द एनोड एंड just over the cathode it will be oxidation. How? We'll see. We'll go with the just next slide. See the matter, read the matter, entire matter properly, because it's too important. Go through with the entire matter properly. You can say the concentration of dilute H2SO4 decreases from 1.30 to 1.20, यानी कि 1.30 से 1.20 तक उसकी डेंसिटी हो जाती है, और डेंसिटी डिक्रीज होते हैं, पर्टिकुलर इसको चेंज करते हैं. And 38% is a by volume percentage. This is the by volume percentage. You have to learn about this by volume percentage. And during the just discharging, concentration means density changes from, you can say, density will change from 1.30 to 1.20 ग्राम पर सीसी। ये वाला बात भी आपको याद रखने वाला है। दिस इज टू इंपॉर्टेंट। Now the time to discuss about the further. What is that? Listen me carefully. That is the recharging reaction. So now we'll go with the recharging reaction of the just lead accumulator cell, or you can say lead storage cell. Before recharging, we'll go with the just EMF also. So now the time to discuss about the EMF. EMF of the lead storage cell or lead accumulator cell is 2 volt for each cell, and by the attachment of by combination of more than one cell, एक से ज़्यादा सेल को सीरियल कॉम्बिनेशन में अटैच करके और बैटरी का फॉर्मेशन कर लेते हैं 2 वोल्ट 4 वोल्ट 6 वोल्ट 8 वोल्ट इस टाइप से। दिस वाज अबाउट द ईएमएफ। नाउ द टाइम टू डिस्कस अबाउट द रिचार्जिंग ऑफ सेल। सेल को कैसे रिचार्ज करेंगे? सो रिएक्शन विल बी इनवर्स। नाउ दिस इज द एनोड नेगेटिव टर्मिनल। यहाँ पर्टिकुलर PbSO4 का चेंज होगा just in, you can say, here will gain of 2 electron because of it's a reverse reaction. It changes in just your Pb and SO4 2 minus, Pb plus SO4 2 minus. You can see gain of electron is called as reduction reaction. Now the time to discuss about the cathode, that is as a positive terminal PbSO4. We have taken just 2 of S2O. Here is 2 of S2O. So what will be? It changes in PbO2, Pb and O2, just 4 of H plus. This is the one of the SO4 2 minus and loss of 2 electron. This was about the just oxidation, loss of electron. So this is the oxidation reaction. If we'll go with the net cell reaction, then what is that? Or you can say recharging reaction. That will be as follows. Net cell reaction, or it is also called as recharging reaction. Recharging reaction. So from 2 electron to 2 electron remains cancelled. Rest it is your 2 of PbSO4 plus 2 of S2O. This is the Pb plus PbO2 plus 4 of H plus, and this is the 2 of SO4 2 minus. You can see the entire reaction. 2Pb 2Pb, SO4 2 2SO4, hydrogen 2 2s are 4, oxygen 4 2s are 8 and 2 10. This is the 2 and 4 2s are 8 and just to 10. This was about the recharging reaction. If we'll go with the just properties of lead storage cell. Lead storage cell. First is your following. Their capacity is 80%. Capacity is 80%, and can be used to 2 to 3 years, 2 से 3 साल तक पर्टिकुलर इन सेल का यूज कर सकते हैं, ईयर्स. एंड जस्ट यू कैन से many times can be recharged. इनको कई बार रिचार्ज किया जा सकता है. Recharge. This was about the just quality or properties of the lead storage cell. Now we'll go with the another secondary cell, that is the NICD cell. This is the very important. This kind of the cell is used in just pagers. This is the pagers. Just you can say mobile phones. Mobiles means all types of the mobile जितने पुराने टाइम के थे उनमें यूज करते थे, पेजर्स पे यूज करते थे. एंड इन कॉर्डलेस फोन में भी इसका यूज किया जाता था. वायरलेस जिसको कहते हैं हम लोग, कॉर्डलेस फोन्स में भी इसका यूज करते हैं. नाउ विल गो विद द जस्ट स्ट्रक्चर. वी कैन से these are costly cell than the lead accumulator cell, and you can say with the great efficiency, with large capacity इनकी lead storage cell से भी ज्यादा होती है, इसीलिए कॉस्टली होंगे. पर्टिकुलर बात करें एनोड की, एंड इलेक्ट्रोलाइट, जस्ट एज एनोड it will use of just Ni. As a Ni, if we'll go with the just, then that is the very important. As an anode we can take just Cd, cadmium, and as cathode it will use of NiO2 का, निकल डाइऑक्साइड का यूज करते हैं पर्टिकुलर. और निकल डाइऑक्साइड के साथ साथ यहाँ डाइल्यूट H2SO4 का KOH का यूज करेंगे एज इलेक्ट्रोलाइट. it will use of dilute KOH solution, पोटेशियम हाइड्रोक्साइड सॉल्यूशन का यूज करेंगे. If we'll go with the just reactions, that is the very important cell reaction, and these also can be recharged. That's why we'll take just the entire reaction as a reversible. First of all, we'll go with the anode, and before taking anode, we'll go with the just electrolyte. This is the 2 of KOH dissociates in 2 of K plus and 2 of OH minus. First of all, we'll go with the anode. As an anode negative terminal, you can take just here is the cadmium, so this is the Cd plus 2 of OH minus. Here will loss of electron, so it will changes in CdOH whole 2 plus 2 of electron. This is the oxidation reaction, loss of 2 electron. Now I would like to go with the just cathode as a positive terminal. This is the cathode. We can take reversible to the reaction because of डायरेक्शन उल्टी भी होगी, इनको रिचार्ज कर सकते हैं. खास बात, here will use of NiO2. This is the just your 2 of H2O. Changes in, here is the gain of 2 electron. Here is the gain of 2 electron. So changes in NiOH whole 2 plus 2 of OH minus. You can see the concentration of electrolyte is constant. दोनों तरफ मिल रहा है, इसीलिए इनका EMF भी आपके पास में पर्टिकुलर कांस्टेंट होता है. And if you go with the just value of EMF, then the constant EMF of 1.40 volt about the just your NICD cell. We'll go with the further also because we'll take just entire reaction, net cell reaction as a discharging or recharging reaction. Go through with the matter properly. As I told you, it's too important. It will complete your 2 question. So there is a lot of part in this kind of the question. So go through properly because of, as I told you, entire chapter electrochemistry is too important. और उसका सबसे ज़्यादा मार्क्स भी यही है after this aldehyde ketone. So be with me properly. Now the time to discuss about the net cell reaction. EMF we have discussed. So what is the discharging reaction and just net cell reaction? So this was about the just NICD cell. So constant EMF क्योंकि concentration आपसे पूछेगा क्यों देता है तो आप कहेगा concentration of electrolytes remains same but these remains cancelled on balancing the reaction. So the reaction will be just net cell reaction, you can say net cell reaction, or you can say discharging of reaction of cell, you can say. So the reaction will be your CD plus, this is NiO2, this is your 2 of H2O. Changes in particular discharge होगा तो ये reaction forward direction में जाएगा. This is the discharging reaction. So it changes in CdOH whole 2, and it changes in NiOH whole 2. This is the NiOH whole 2. CD is balanced, Ni is balanced, oxygen 2 and 2 4, 2 and 2 4 oxygen and 4 hydrogen. This was about the discharging, and on recharging reaction will be inverse. So this was about the just type of the cell or batteries. Just you can say as a secondary cell we have discussed about the lead accumulator cell, means lead storage cell, and NICD cell which is used in cordless phone, pagers, etc. So go through the matter with the properly. So dear student, doctors and engineers of the near future and all the chemistry lovers, will meet in the next video. Till then, शुक्रिया, धन्यवाद, इन्हें अपना प्यार देते रहिए. अगले वीडियो में हम बात करेंगे पर्टिकुलर फ्यूल सेल की और कोरोजन की. तब तक के लिए शुक्रिया, धन्यवाद.